Hey guys, section 7.7 is on approximate integration. Uh, For some definite integrals, even if we can't evaluate them using the fundamental theorem, we can still approximate them by approximating the area under the curve. So the three most common ways of doing this are what's called the midpoint rule, the trapezoidal rule, and Simpson's rule. Now, the midpoint rule is very similar to what you did in Calc 1 when you first started learning about integrals. So what I want to do today is I want to talk about the midpoint rule and do a little bit with it. We'll talk about the trapezoidal rule, but then we're going to focus on Simpson's rule pretty strongly because it's the best approximation of the three. So let's look at midpoint rule. The midpoint rule is written out like this in the textbook, and what this is saying is you've got a bunch of rectangles, and the midpoint rule says that the approximate area under the curve, this integral, is equal to delta x times all these f values. Delta x is b minus a over n. So what that is, it's the width of the rectangles. So you're multiplying the width here by all of the heights added together, and that gives you the total area of all those rectangles. So like in this example here, this is the integral. Well, it's the one up there. Integral of from -3 to 1 of x cubed plus 3x squared. So this is -3, this is 1, and we're doing four intervals, 4 rectangles. And the midpoint rule just says you get the height of these things by looking at the midpoints here. So in this case, our the x values that we put in here, this, let's see, let me get it on screen. This x1, x2 bar, and so on, that would be, in this case, those midpoints. So this is -3 right here, so this is -2.5, this is -1.5, -0.5, and then +0.5. So the idea here is you'd do f of -2.5 plus f of -1.5 plus f of -0.5 plus f of 0.5. And then you add those up, and then you multiply it by the width. Now the width in this case is, you can look at it and tell the width of these things is 1. But that also comes from the formula b minus a over n, because b minus a over n would be, that's supposed to be a delta x, not an ax. It's b, which in this case is 1, minus a, which is -3 over 2. Or not over 2, over n. N in this case is 4. So that gives you 1. So if you were to go through the trouble of multiplying this stuff out, that would give you an approximation of the integral. Now, it's obviously not a very good approximation because you're going to miss this area here and here and here and here. And you're also going to miss this area inside of here and there. And you're going to count some extra stuff over here that is not really part of the integral. Yeah, this is extra over here. Anyway, you'll get some error. And you can improve the error by using more rectangles. So like over here, this is using 8 rectangles instead of 4. Now, I'm not sure if I've shown you this before or not, but there's an online calculator. You can get to this from my webpage, area under a curve. And this uses the midpoint rule. Well, it actually gives a couple of options for what to use. And one of them is the midpoint rule. If I set this to midpoint, and I give it the function we were looking at, x cubed plus 3x squared. There's the functions just like it looked before. Let's do n equals 4 and go from 0 to, or no, go from -3 to 1. And I've got to click this thing to draw the rectangles in. Those are the rectangles we just looked at. And I'll zoom in on it a bit. So that would give us the area, and the area that it's coming up with is 8. And if I change this from 4 to 8, it gives us a better approximation. Well, it still just says 8. But as this goes up, we get better and better approximations. It turns out all these are just giving us 8. I guess that's the exact answer. But in general, as n goes up, you get better and better approximations. All right, well, let's look briefly at the trapezoidal rule. You know, a trapezoid is a shape that it's a quadrilateral that has 2 sides that are parallel, and then the other 2 sides are not parallel, or not necessarily parallel. So that's a trapezoid. And the idea behind the trapezoidal rule is, instead of drawing in rectangles, come in here and draw in a straight line from here to here. Let me pick a thinner line to use. So if I draw a thin line from here to here, now that one gives us a triangle. But this one over here gives us a trapezoid. And then this, and then this. So if we did this and we found the area of each of these trapezoids, that would be a better approximation. Because instead of just going straight across, we're kind of averaging out the 2 endpoints when we're finding the top. So this is a better approximation. And the formulas for that are given down here. But I don't want to spend much time on this because I want to really talk about Simpson's rule.